Welcome to Unit 6. We're going to talk about electrochemistry. Electrochemistry is very closely related to redox or reduction oxidation reactions. And this intro lesson here is going to help you make sure you can identify those types of reactions from each other and apply them to some components within electrochemistry. So what does this word electrochemistry make you think of? If you're saying something like electricity, electrons, anything like that, you are spot on. Another thing that can kind of help zone you in on what's going on here is these are a couple of reactions that are related to electrochemistry. All right, you'll notice one involves one makes electrons, the other uses electrons. All right. And electrochemistry is defined as the study of the conversion of chemical energy to electrical energy and vice versa. All right, so electrochemistry is electricity and chemicals. And we do this by transferring electrons. All right, that transfer of electrons occurs through two different reactions. So electrochemistry always has both of these going on. We call these reactions redox reactions, and there are two halves to this. There's a reduction half reaction, and then an oxidation half reaction. So here is a definite good slide to take some notes on, and some hopefully good hints to help you remember these things. So an oxidation half reaction, you have an element that loses electrons. All right, so you can see in here you got your zinc solid, and then after the reaction, zinc is positive, has a positive ion, and has given away 2 electrons. All right. What I use to remember this is the term Leo, like Leo the lion. All right. Lose electrons, oxidation. Reduction, on the other side, you have an element gaining electrons. All right. This is where that whole transfer of electrons occurs. So if you have an element gaining the electrons, you're going to have something that starts out as an ion, and then it's going to combine with some electrons and form a solid metal. All right, my way to remember this is grr, like the noise that a lion makes, but gain electrons reduction. All right, so your electrons always travel from the site of oxidation to the reduction site. All right, so a redox reaction always has to have these two halves. Electrochemistry always has to have an oxidation and a reduction reaction. So there are two major kinds of electrochemical cells or types of electrochemical reactions. You've got your voltaic cells, sometimes also referred to as galvanic cells, and these will convert chemicals to electricity spontaneously. All right, so on their own, you don't need to input any energy. Whereas electrolytic cells can convert chemicals to electricity, but it's non-spontaneous. So that means that you have to input some sort of energy. That's why an electrolytic cell always has like a battery or a power source shown in it, whereas the voltaic cell does not. All right. So in the reactivity series was mentioned on the other side. This kind of helps determine if something's going to be spontaneous or a voltaic cell or non-spontaneous or electrolytic cell. All right. So if you have it set up where you have, say, barium and copper. All right? And you want the barium to give up its electrons and the copper to gain electrons. All right? You're going to have a spontaneous reaction. So the higher up on this list, the more likely that element is going to oxidize. And the lower, the more likely that element is going to reduce. All right? And this is based on, spontaneousness. If you want the opposite to happen, say you wanted copper to oxidize and barium to reduce, you'd have to put this into an electrolytic cell. All right? So things most active will spontaneously oxidize. And then the closer to the least active, those are the ones that are going to spontaneously reduce. You can force them to do the opposite, but that requires an electrolytic cell.